Module 2 is our deep dive. The goal is to master the core workloads: data engineering, data warehousing, and data integration. We begin with data engineering. A best practice here is the medallion architecture, which structures your data into 3 layers: bronze for raw data, silver for cleaned and validated data, and gold for curated, aggregated data ready for BI. For transformation, we primarily use Spark notebooks, PySpark for custom transformation logic, or Dataflow's Gen 2 for a low-code interface to ingest, clean, and write transformed data directly into Delta Lake tables. Let's jump into our demonstration. For this demonstration, I will show you how to develop a basic data transformation using a notebook with PySpark. Our goal is to create a new Delta table from a transformed PySpark data frame. From our development workspace, click New Item at the upper left corner. Search for Notebook, select it, name it Fabric Training_Notebook, and click Create. On our notebook canvas, we'll start by loading our lakehouse. Click Add Data Item, choose Existing Data Sources, select Fabric Training_Lakehouse, and click Connect. Next, go to our target table, click the ellipses, and select Load Data using PySpark. Our objective for this demo is to create a filter that shows only first-class Titanic passengers who survived. We'll begin by creating a function named clean_data, using the data frame .filter syntax where both class equals 1 and survived equals 1. After creating the function, we'll call it and assign the output to a new variable called clean_df. Let's display the data frame to verify that our filter is working correctly. Finally, we'll write the resulting data frame to a new Delta table within our target lakehouse. Now let's run our code and preview the resulting data frame to confirm that our filter logic worked correctly. Once validated, refresh the table section of our lakehouse. You should now see the newly created Delta table Titanic_first-class_survivor. As a final check, select the table to ensure that rows were successfully written. That concludes our notebook with PySpark demonstration. For this demonstration, I will show you how to build a basic data transformation using Dataflow Gen 2. Our goal is to produce a new Delta table based on transformed data inside the data flow. From our development workspace, click New Item at the upper left corner. Search for Dataflow Gen 2, select it, name it Fabric Training_Dataflow 2, and click Create. On the Dataflow Gen 2 canvas, click Get Data from another source, choose Fabric Training_Lakehouse, and select the Delta table Titanic_with_dupes. Review the data in the data preview, then click Create to load it into the data flow. Our objective is to produce a new Delta table that contains only Titanic first-class survivors, similar to what we created in the PySpark demo. But this time, we'll add additional logic using a custom column to determine if the passenger is a minor or not. Let's start with filtering. Click the drop-down on the survived column and filter the value to 1. Do the same for the P-class column and filter it to 1 as well. Next, let's add our custom column. Since the age column contains null values, we'll tag those records as not applicable. Go to Add Column, select Custom Column, and name it as minor. Set the data type to text, then use this logic. If age is 18 or older, set value to not minor. If age is equals null, set value to not applicable. Otherwise, set value to minor. Click OK and verify the new column in the preview. Once validated, proceed to configure the destination. Choose Lakehouse as the destination. Select Fabric Training _ Lakehouse and name the new Delta table. Titanic _ First Class _ Survivor _ Data Flow Gen 2. Review the column mapping, then click Save Settings. Finally, click Save and Run. Return to the development workspace to monitor the publishing and execution. After the run completes, refresh your Lakehouse tables and select the top 100 rows of the newly created Delta table to validate the results. Next, data warehousing. Fabric offers a traditional SQL database for Transact SQL-based enterprise reporting. Alternatively, the T-SQL endpoint provides a read-only SQL interface for querying your Lakehouse's Delta tables directly using T-SQL. For data loading, we use familiar T-SQL commands like copy into to load data from external locations and ctos create table as. Select to transform and load data in a single step. Let's jump to our demo. For this demonstration, I will show you how to use copy into and ctas create table as select in Microsoft Fabric using an existing warehouse. At the moment, Lakehouse does not fully support DML Transact SQL syntax, which is why we will use a warehouse for this demo. First, we will load external data using copy into. To prepare the source file, go to the Training Lakehouse, right-click the Files folder, and select New Shortcut. Choose External Sources, then select SharePoint folder, and create a new connection using the SharePoint link. Once connected, locate the Titanic folder containing the CSV file and complete the shortcut creation. Next, navigate to the warehouse. Since the table does not yet exist, create a new table named Titanic _ with dupes, defining the required columns and data types. To perform the copy into, open the CSV file properties from the shortcut. Copy the absolute path. Use it in the copy into statement along with the CSV options. Run the statement to load the data from SharePoint into the warehouse table. Once completed, validate by selecting records from the table. Next, we will use ctos to create a transform table. We will create a new table named Titanic _ First Class _ Survivors with the following logic. Select records from Titanic _ with dupes table that we just created and inserted rows earlier. Filter passengers where P-class = 1 and survived = 1. Add a calculated column is minor using a case statement. If age is greater than or equal 18, then the value is not minor. If age is now then, the value is not applicable. Else, the value is minor. Run the ctos statement and validate the results by querying the new table. You should see only first-class survivors with the correctly derived is minor values. That concludes our demonstration of copy into and ctos in Microsoft Fabric. For this demonstration, I will show you how to connect a Microsoft Fabric warehouse to Power BI semantic modeling. We will use the existing warehouse that we worked on in our earlier demos. First, switch from the Fabric portal to the Power BI portal. On the Create tab, select OneLake as the data source, then choose Warehouse and click Connect. Since we are using a Fabric data source, specifically a warehouse, Power BI automatically configures the semantic model to use Direct Lake mode. Enter Titanic _ semantic model as the semantic model name. Select the transformed table that we created earlier using CTAS and click Confirm. Once the model is loaded, you can add more tables as needed to perform data modeling, such as creating relationships, measures, and calculations. That concludes this demonstration. Our final workload focus is data integration using Data Factory. Pipelines orchestrate data movement and transformation using activities like copy job and notebook. You can control the flow using branching with if condition or looping with for each. For reusability, we heavily utilize parameterization. Let's move on to our first data integration demo, Pipeline Fundamentals. For this demonstration, I will show you how to build a basic ingestion pipeline in Microsoft Fabric that ingests multiple files and, after a successful ingestion, automatically triggers a notebook for data transformation. To begin, navigate to our workspace where I have already created a folder named Fundamentals. Inside this folder, create a new pipeline and name it Fundamentals_pipeline. Our ingestion method for this demo will use a copy job. The data source will come from the Lakehouse Files folder. I previously created shortcuts from a SharePoint folder containing the orders and returns files into our Lakehouse. This provides a semi-live connection. Any new file added in SharePoint will automatically appear in the Lakehouse and be picked up by the pipeline. Next, create a new copy job and name it Fundamentals_copy job. Set the source to the Lakehouse files and select both the orders and returns folders. Review the file preview and adjust the settings as needed, such as removing the quote character. For the destination, select the Fabric Warehouse, choose Full Copy, and use the store schema. Review and validate the column mapping for both datasets. Then save and run the copy job. Once completed, confirm that the expected number of rows has been ingested. Now return to the pipeline canvas and add the copy job activity. Rename it to Ingest Multiple Files from SharePoint. Then select the copy job you just created. Next, we will add a notebook activity to perform data transformation. From the warehouse, create a new SQL notebook. This notebook will drop the target table if it already exists. Perform a CTOS create table as select operation. The transformation logic joins the orders and returns tables using a left join on order ID, filters records by year. And creates yearly tables such as orders underscore with underscore returns underscore 2015, orders underscore with underscore returns underscore 2016, orders underscore with underscore returns underscore 2017. A calculated column is added using a case when statement to handle null return values by labeling them as not applicable. Save the notebook and return to the pipeline. Connect the notebook activity to run on success after the copy job. Rename this activity to data underscore transformation underscore notebook. Select the notebook, save the pipeline, and run it. Once execution completes, refresh the warehouse and validate that the transformed tables have been created under the store schema. Select each table to confirm the data and ensure the return logic has been applied correctly. This completes the demonstration of a pipeline that ingests multiple files and performs automated data transformation using a notebook in Microsoft Fabric. Let's jump into our second data integration demo and walk through the control flow and Microsoft Fabric pipeline. For this demonstration, I will show you how to implement a basic control flow in Microsoft Fabric using lookup and for each activities. Our goal is to retrieve a list of tables dynamically from a warehouse schema and back them up to a lakehouse folder after ingestion and transformation as Parquet format. We'll be backing up tables from the store schema in our warehouse to Fabric Training_Lakehouse, specifically to a folder named Backup. First, we'll use a lookup activity to retrieve the list of tables to process. Rename the activity to Get Table List. Connect it to our warehouse. Use a query to retrieve base tables from the store schema. Select table_name from information_schema.tables, where table_type equals base table, and table_schema equals store. Preview the query to confirm it returns the expected table names. Next, we'll process each table using a for each activity. Add a for each activity and rename it to for each table. Enable sequential execution. Set the item's property to the lookup output value. This allows us to loop through each table returned by the lookup activity. Inside the for each activity, add a copy data activity. Rename it to Backup Tables. Source type, warehouse. Schema name, store static. Table name, dynamic value from the for each iterator at item.table_name. Destination type, lakehouse. Select the public training lakehouse. Target folder, files/backup. For the output file name, use a dynamic expression that includes the table name. A timestamp converted from UTC to EST. This ensures each backup file is uniquely named and time-stamped. File format, Parquet. Before running the pipeline, I will first deactivate the activities that are not part of this demo to keep the execution focused on our control flow scenario. Save and run the pipeline. If an error occurs, ensure that first row only is unchecked in the lookup activity. Once corrected, rerun the pipeline. You'll see each table processed sequentially. You can inspect the input and output of each iteration for validation. Finally, navigate to the lakehouse, refresh the backup folder, and confirm that all tables from the store schema were successfully backed up as Parquet files. That concludes our control flow demonstration using lookup and for each in Microsoft Fabric. Let's jump into our last data integration demo and walk through the parameterization in Microsoft Fabric pipeline. For this demonstration, I will show you how to implement parameterization in Microsoft Fabric pipelines. We will reuse the same pipeline created in our earlier demos. The goal here is to make the pipeline reusable and dynamic, allowing us to back up any warehouse and any schema without modifying the pipeline logic. First, let's set up our pipeline parameters. We need 3 parameters. Param_schema for the schema to back up. Param_warehouse for the target warehouse. Param_SQL_connection for the SQL connection string. Note that when parameterizing a warehouse, the SQL connection string must also be parameterized. This is a required setup in Fabric. The parameterization will mainly affect the lookup and copy data activities. Open the lookup activity. For the warehouse, switch to dynamic content and select param_warehouse. Do the same for the SQL connection, selecting param_SQL_connection. Next, parameterize the SQL query. Replace the static query with a dynamic expression. Use concat to build the query and inject the param_schema value. After configuring this, click Preview Data to validate. Enter test values for the parameters and confirm that the list of tables is returned correctly. To copy the SQL connection string, open the warehouse. Click the Settings gear icon. Go to the SQL Endpoint tab. Click Copy. We'll use this value when running the pipeline. Now, move to the Copy Data activity inside the For Each loop. Previously, the schema name was hard-coded. This time, set the schema field to dynamic content. Select the param_schema parameter. This ensures the backup works for any schema we pass at runtime. Click Save and Run. You'll be prompted to enter parameter values. Schema, for example, DBO. Warehouse name. SQL connection string. Click OK to start the run. The lookup activity should succeed and return the list of tables. The For Each activity will iterate through each table. Each table will be backed up to the Lakehouse backup folder. Finally, refresh the Lakehouse and confirm that all tables from the selected schema were successfully backed up. That concludes our pipeline parameterization demonstration.